we will study the simple pendulum experiment. During this study, we need to know what is simple pendulum, aim of experiment, equipment, theory of experiment, classical method of experiment, photo and analyze method of experiment, analyze the experimental results, finally results and errors. The simple pendulum offers a method of measuring the constant acceleration due to gravity very precisely. The simple gravity pendulum is an idealized mathematical model ideally defined as a particle suspended by a massless string. Practically, it consists of a small body, usually a sphere, suspended by a string whose mass is negligible in comparison with that of the sphere and whose length is very much greater than the radius of the sphere. Under these conditions, the mass of the system may be considered as concentrated at a point, namely the center of the sphere, and the problem may be handled by considering the transitional motion of the suspended body, commonly called bob, along a circular arc. When a bob given an initial push, it will swing back and forth at a constant amplitude, moves without damping. Each one oscillation or cycle called period. The period of a simple pendulum is the time it takes to swing from one side to the other side and back again to the same point. This figure represents a simple pendulum swing or oscillate from one point maximum point and go through equilibrium point to the other side to a maximum point, where two maximum point have to be at the same line or at the same plane. Purpose or aim of experiment. The aim of this experiment is to calculate or to determine the experimental value of acceleration J due to gravity using angular frequency omega, where omega equal to pi divided by t, and t is the period of the pendulum. Of course, using angular frequency omega of the simple harmonic motion SHM of the simple pendulum. Apparatus and materials. We need two groups of tools. The first group, classical required tools, stopwatch, clamp, stand, pause, protractor, metric, ruler, a massless string of a certain length, unstretchable, J-clamp, diagram sheets, a mass of simple pendulum bob. The second group of tools, we need camera video more than 60 FPS, mathematical programs or Microsoft Excel, and PowerPoint, of course, movie maker software programs, Photoshop and Flash softwares programs, converter programs, montage software programs, computer with full Microsoft Office. These tools which we need to accomplish this experiment. Theory of experiment. Figure on the left show us there are two forces acting on the mass. The tension T and the gravitational force mj. The tension T cancels the radial component of the gravitational force. The other component of the gravitational force is the tangential force, which equal minus mj sine theta. Tangential force or restoring force is accelerating the mass towards equilibrium along the arc of the circle. This component is called, as I mentioned, the restoring force of the pendulum, which equal, according to second Newton's law, F restoring equal mass time tangential acceleration. Where tangential acceleration equal second derivative of s with respect to the time, where s is the pop, where s is the pop's position measured along the arc, and the negative sign at the another side minus mj sine theta indicates that the tangential force acts towards the equilibrium position. If the angle theta less or equal 10 degrees, we could write S equal L theta and sine theta approximately equal theta. Under this condition, we could rewrite the equation above as following. Length time second derivative of theta with respect of time equal minus j theta. We get theta double prime equal minus j divided by L time theta. Theta double prime always on the opposite sign with theta or position, where theta double prime is angular acceleration. Here J divided by L is a constant of the second order differential equation. Which is equal constant square. This constant in physics called angular frequency. And its symbol omega. That's mean omega square equal j divided by length. The relationship between period and angular frequency is T equal 2 pi divided by omega. We could now write the final equation to the period of the simple pendulum. T equal 2 pi under square root length of the pendulum divided by J, gravity acceleration. In this experiment, we need to get J. If we know L and t. And this experiment is prepared to calculate L and T. Of course, if we know T and L, we will know J. Gravity acceleration. By experimental procedures, we will get J. How to calculate J from experimental result? There are many ways to calculate J. I am here to explain one of these methods by two ways. The first way, square the two sides of the period expression after square will become t square equal 4 pi square L over J. From this equation, J equal 4 pi square divided by t square over L. Because we put L in denominator of t square to get physical slope from experiment results, which mean t square over L when we using graphs of t square versus L will get M, where M physical slope from experiment. Then J equal 4 pi square divided by M from the analysis of experimental result. The second way, using graphs of L versus t square. And after squaring the two sides of the period expression, we will get J equal 4 pi square L divided by t square. I will consider here L divided bt square is the physical slope from experimental uh, results, and if we graph or make a graph of L versus T, will give us M prime. Where the value of M prime equal 1 over M in the first way. The two-way is very useful, and generally we use this two-way to calculate the physical slope from experimental results.